In this part of the chapter, we'll be learning about flame. Mainly, we'll be learning about the candle flame. We'll be learning about those substances that burn with the flame and those substances that do not, and what parts of a candle flame they are hottest and what parts they are the very least hot. Okay. There are two types of combustion mainly. One is the rapid combustion and one is the spontaneous combustion. Okay, so the word rapid means quick, right? And the word spontaneous means occurring all out of a sudden, all right? So, owing to this definition, rapid combustion is quick combustion. For example, when you use an LPG cylinder at your home and you turn on the gas knob and you immediately, light it via a lighter or a candlestick, you observe that the gas it burns rapidly and it produces heat and light. So the gas burns with the flame. All right, it is undergoing chemical reaction. It is burning with heat, light, and of course, energy is being released. Okay, such combustion is known as rapid combustion. Okay, so also paper that also undergoes rapid combustion. And you have already seen LPG. So any other type of petroleum product like kerosene, like petrol, okay, they also burn very rapidly. Means they also burn very quickly. Means the ignition temperature is low, and immediately when a source of energy or heat is provided to them, they start burning. All right. Whereas spontaneous combustion, on the other hand, they burn suddenly, out of a sudden, and usually they burst into flame. Means their process of combustion is not quick, it is rather occurring out of a sudden. And when something occurs out of a sudden, it's very hurried, it's very loud, right? That is why it is bursting into flames. So it quickly catches fire, and not in the case that we have seen the rapid combustion. Rather, it's so quick that it feels it's automatic. This is mostly in the case of phosphorus. Now, like while explaining how a matchstick works, I had told you that phosphorus it is readily combustible at room temperature, right? Specifically the white phosphorus one. Okay, so the phosphorus, when it is introduced to the room temperature, all right, it immediately catches fire. No rapid combustion is happening. All right, means no external source of heat is being provided. All right, the process of catching fire is so quick and it is so sudden that it almost bursts into flame. All right, that is what we mean by spontaneous combustion. All right, and since we did not apply any external source of energy, we did not give that piece of phosphorus any other source of heat. All right, it burned on its own. All right, therefore the type of combustion in which a material suddenly bursts into flames without the application of any apparent cause or without the application of any external source of heat or any external source of energy. All right, it is so quick, it is so fast, and it is so sudden that it feels that it is it was burning all the while on its own. It's automatic. All right, so without the application of any apparent cause, and it's burning suddenly, it's burning with flames, bursting mostly with flames. Therefore, the name spontaneous combustion. Okay, and spontaneous combustion of coal dust has resulted in many disastrous fires in coal mines. So, apart from phosphorus, coal dust is also the product that you get when you are mining coal. All right, and its combustion is also spontaneous, and it is basically the cause of fire in many of the coal mines. All right. Now, forest fires, they are spontaneous in nature. If you recall that slide where we had learned about forest fires, we had learned that the dry grasses or dry twigs or whatever dry vegetation, low vegetation they are there, they in extreme of heat, all right, they are basically burning. So when an extreme of heat or extreme of sunlight is getting directed towards those dry grasses, those dry vegetation, they catch fire on their own. So you do not need to go there with a lighter. You do not need to go there with any other combustible substance in order to lighten them up. Just in the presence of high temperature, they will start burning. All right. So when they will start burning, naturally, after a while, they will also cause the larger trees, the smaller trees, and the vegetation around it to start burning. All right. So spontaneous forest fires, That is how they happen. And sometimes they are also caused due to lightning strikes, and they are also caused due to the carelessness of human beings. So when lightning it strikes a tree or any other high vegetation area, all right. So you know that along with the lightning bolts, there is also an immersion of there is also an expulsion basically of heat and energy. All right. And if that temperature is so sudden, it's so hot, it's so high that the ignition temperature of that wood is reached, then immediately it will start burning. Okay. So the lightning bolts, they carry themselves, they carry heat and energy with them. Okay. And obviously high temperature, since there is heat and energy. So when they will strike that piece of wood, that high piece of tree, there it may happen so that their ignition temperature is reached and they may start burning on their own. All right. Another cause of spontaneous forest fires. Then the third cause of spontaneous forest fire is the carelessness of human beings. Mostly in the cases of campfires, okay, or bonfires, what happens that sometimes some people, they do not extinguish the fire. All right. So this fire that you see over here, this piece of wood is lighted, and then dry twigs, they are used as the source of fire for roasting meat or for roasting other eatable items, marshmallows and stuff. And also for bonfires, you have lighted fire in the middle and people are gathered around the fire and they are discussing and talking and all that. Okay. So in some cases, some people, they do not extinguish fire. Means those dry twigs, they still have fire, they still have fire lighted over them. So what will happen if that fire is not extinguished, and if that dry twigs is surrounded by other vegetation that is also say dry, or also say combustible, or also or the fire, the source of fire is so high that it may easily increase the ignition temperature of the surrounding vegetation, even though they are not dry. Understanding? So in that cases also what will happen, a chain reaction will occur and a forest fire will happen. So this is how spontaneous fires they occur. All right. So it is very important that before leaving a forest, or after a picnic or a visit or anything, if you have lighted the fire, you make sure that that fire is completely extinguished so that it may not lead to any kind of spontaneous forest fire. Have you seen fireworks on festival days? You must have. In India, it is a must. In case of New Year's Eve, in case of if your favorite cricket team or football team has won a very important match, or of course, in the cases of festivals, in the cases of Diwali, in the cases of Dashera, all right, or any other festival in which you may like to celebrate with fireworks. So, in a country like India, it is a must. Now we come to this part, explosion. Okay, so explosion, you can view this as a kind of spontaneous um combustion, but the only difference here is that spontaneous combustion, you are not applying any external source. All right, you're not uh you're not giving that combustible substance any other extra heat in order for them to burn, in order for them to combust. All right, whereas in explosion you are. So there is a difference. This is basically a huge difference. But the you may say the after effect, since in spontaneous explosion it bursts with flames. Means if you are putting a very small quantity of phosphorus and exposing it to the temperature, room temperature, it may burst with it may burst, all right, into flames. But if you say, if that same phosphorus is very large in quantity, then what will happen? Okay, a large sort of spontaneous combustion is going to happen. All right. So this after effect that I'm trying to talk about is what you see in a case of explosion. In the case of explosion, of course, you are using a different source of an external source of combustion in order to ignite that combustible substance. But when that combustible substance is burning, it is exploding. Means it is so sudden. All right, the combustion is so sudden and it is so loud that it explodes, evoluting heat, light, and sound. So heat, energy that is getting, of course, that is being released. Apart or besides this heat and this energy, you also have a massive display of light and a massive release of sound. So a kind of a noise pollution. So firecrackers, when they burn with an explosion. Okay, because you are applying a matchstick or any other source of energy. Okay, and they burst spontaneously, immediately, and the consequence is that they burn with a massive display of heat, light, and sound. A large amount of gas is formed in this reaction, and such a reaction is known as explosion. Explosion can also take place if pressure is applied on the cracker. Yes. Now, finally, we come to our discussion of flame. What do you mean by flame? Flame comes from the Latin word flamma, which means visible. So, flame is nothing but the visible gaseous part of the product, okay, that catches fire. So, that visible gaseous part of fire is known as flame, and it is caused by a highly exothermic chemical reaction. So chemical reaction, we know that combustion is a chemical reaction, and exothermic, we know that the word exo means this prefix means out. All right. So exotherm and therm is heat. So exothermic, in which heat is getting dissipated or heat is released. All right. So in such a reaction in which heat is released, of course, in combustion, you know that heat and energy is they are released. Okay. And you know that combustion is a chemical reaction. You can also say, in other words, that combustion is an exothermic chemical reaction. So in an exothermic chemical reaction, which occurs in a thin zone, all right, in a thin zone, and in occurrence of some gaseous particle. So that gaseous particle may catch fire, and when that gaseous particle it catches fire, it burns with this luminous flame, all right, which is visible to our naked eye. Okay, luminous flame. Luminous flame means bright flame. Okay, that flame may be blue, that flame may be yellow, depending on whether the combustion is taking place fully or not. So what happens in that is that in some fuels, there is enough oxygen, all right, and the combustion that is taking place means the gaseous particles that are burning, that are absorbing a lot of oxygen, and they're burning completely, they're burning fully, means whatever hydrocarbon constituents of hydrocarbon that is being burned, that is being completely burned, means there is a complete combustion occurring. All right, complete combustion of what? Complete combustion of the fuel. And what is the fuel made of? The fuel is largely made up of hydrocarbon, or is largely made up of carbon. So the carbon content is consuming the oxygen, and it is burning with a complete combustion, means the residue, it's not leaving residue, or it's not leaving a lot of residue. And this complete combustion indication is a blue flame. And when you have a yellow flame, it is basically an indication that there is an incomplete combustion. Means the hydrocarbon, or the source of carbon, that for the fuel that is burning, that is not utilizing a lot of oxygen to burn all the carbon content in one go. Okay, therefore it will burn with a yellow flame. So if you have observed the LPG flame that burns in your house, you may observe a stove that the innermost circle, especially, that burns completely, means all the carbon particles of that LPG, it's burning and it's utilizing oxygen, it's undergoing complete combustion. Okay, whereas the candle flame, it is yellow, although you may observe that the external part, outermost part, it is blue, all right, whereas the innermost part or the mid part, it is basically yellow. Okay, so this yellow is an indication that an incomplete combustion is happening, means the carbon content there that is burning in that area, it is not being burning, it is not burning completely, means it is leaving out some residue, and means that it's not basically utilizing or consuming a lot of oxygen. Whereas the outermost area is basically a very thin blue radiance is there. That is an indication that around that area, a complete combustion is happening, means all the carbon, it's being combusted, and there is very little to no residue, and or it's utilizing a lot of oxygen, because more oxygen than the part of the yellow flame, because of course the carbon, it's all getting it's all getting burned, it's all getting consumed. Now, materials forming flame on burning. So candle, you know that it forms flame. Magnesium, you know that it does not form a flame. Okay, so why does it not form flame? Because magnesium, it burns with a glow, just like charcoal. So charcoal will not form flame. Charcoal will not form flame, because charcoal does not, its gaseous part does not burn with some visibility. Rather, the whole of the length of the charcoal piece, or maybe the whole of the length of the magnesium ribbon that you were burning, that burns with the glow, releasing carbon dioxide and water, etc. But not any gaseous visible part. Camphor, yes, camphor will form flame. Kerosene stove, you had seen in the previous slide, it will form flame. Okay. How is flame produced? For this, we are going to look at an experiment. We are taking a lighted candle and we are taking a glass tube. This glass tube is a long, thin glass tube. So tube means there is a hollow part. All right, this is a cylindrical glass tube like this. Okay, so the sides of this is the glass body, and this part is hollow. Okay, this part is hollow. So you have taken a 4 centimeter long, thin, means the diameter is thin. Okay, glass tube with a pair of thongs, and you are introducing its one end towards the dark zone of the non-flickering candle flame. The dark zone means the innermost part. All right, so if this is your candle flame, okay, so this part, this portion, this is the darkest portion, this is the innermost portion. All right, means that portion where your wax is basically vaporizing to form gaseous particle that is being burnt. All right, I'm repeating it for you. The darkest portion or the innermost portion is that area where the candle wax, it is vaporizing, because you know that a flame is the gaseous visible part that is burning. So this candle flame, it is the where the vapors of this candle wax, they are present, is the darkest or the innermost area of that candle flame, and you are introducing one part, say the end A of the candle of this glass thin rod towards this candle flame, and the B part you have put a lighted matchstick towards that end. Now you have to observe. You will observe that the flame is caught at the matchstick end side of the glass tube after a while. Means the although the glass tube does not burn with the flame, we have observed, we have established this fact that glass does not burn with a flame. But you have observed also in this experiment that when you put this A part towards this, the innermost part of this candle, all right, you introduce this A part towards here, and you introduced one lighted matchstick over here. You observe that this part of the glass rod, it started burning with the flame. Why? Because this part, this innermost candle, if you may remember, is that portion where the candle wax vapors are present, right? The candle wax vapors are present. And why they are present? Because you know that flame is nothing but the visible burning gaseous part. Okay, so that gaseous part is burning, and basically vapors, you are introducing the candle vapors directly to pass through this hollow tube from end A to B. Okay, so candle vapors are directly passing from end A to B of this glass rod, and of course, when those candle vapors, they're exposed to this matchstick, this source of heat, it is catching fire. So the vapors of wax coming out of the glass tube produces flame. Okay. Why coal does not produce flame? So you know that coal, there is no visible gaseous particle inside the coal that is producing any flame. Rather, the whole of the coal particles, they are burning with the radiance, they are burning with the glow. The substances which vaporize during burning, only they will produce flame. Why? Because flame is nothing but the visible gaseous particle that is burning. The gaseous part, visible gaseous burning part. Okay, so since coal, it does not give out any gaseous, means the body of the coal is burning, there is no gaseous particles of the coal that are burning, therefore coal would not produce flame. For example, kerosene oil and molten wax, they rise through the wick. All right, they vaporize basically, and those vapors of kerosene oil and those vapors of the molten wax, they catch fire. They catch fire while burning. They are vaporized during burning, okay, and then they produce flame. Whereas charcoal or coal that you have, they do not produce flame, alright, because they do not vaporize. The whole body, as you can see in this picture, they burn, and they burn with the radiance, they burn with the glow. To observe, I told you, right, that in a candle flame, or obviously, and also in your LPG gas stove or in a kerosene gas stove, there is a blue flame and there is a yellow flame. And I told you the difference, that the blue part is where you will have complete combustion, means all the carbon particles all the carbon particles, they are getting burned completely via the absorption of oxygen. And towards the yellow part, you will observe incomplete combustion, means all the carbon particles are not getting combusted, are not getting burned. So for this experiment, you take a candle flame and you introduce a clean glass plate. This is that clean glass flame to the flame, and you hold it there for a few minutes, say 10 seconds, and then you remove it. After you remove it, you will observe, like here you can see here in this picture, a circular blackish ring is formed, and this is nothing but the unburnt carbon particles. It indicates the deposition of unburnt carbon particles present in the luminous zone in the flame. Luminous zone means the bright zone. Luminous bright zone is the yellow zone. So in the yellow zone, you have the unburned carbon particles, and when you put the glass plate or the glass slide, so basically you can observe, you cannot visually observe that where are the carbon particles that are going unburned. So when you put that glass particle, get that glass plate or that glass slide above the candle flame, so you will notice that since there is an incomplete combustion going on in the yellow and luminous part of the flame, so there must be some carbon residue that are getting left, that is unburned. So those blackish unburned carbon particles are going to be deposited on the glass slide. And to another for another establishment that flame has a high temperature, we'll be looking at this last experiment. We are holding a thin long copper wire just above the non-luminous zone of the flame, means that zone of the flame which is not bright yellow. Okay, so that zone of the flame that is bluish in color, that is not yellow in color, just the outermost area. Okay, so the luminous zone, if I may the luminous zone is the yellow part, which is almost the mid and the almost the mid area of the candle flame. All right, and the non-luminous area is the blue part, the outermost part of the candle flame. And you know that we have already seen this in the previous experiment, that the yellow, in the case of the yellow flame, that luminous flame, there will be unburned carbon particles. In the case of blue flame, that is a non-luminous flame, since there is we know that in blue flames the carbon particles are getting burned completely, so there will be less to negligible carbon residue. So here in this experiment, we are holding a thin copper wire just inside the non-luminous zone, the bluish zone of the flame, for about 30 seconds. And immediately you'll notice that the portion of the copper wire just outside the flame, means this portion, this will get red hot, means it is getting hot very, very, very quickly. The non-luminous zone of the flame, the bluish part, therefore, has a very high temperature. So to sum things up, let's look at the structure of the flame over here. This is your candle wax. This is your candle, okay, and this is the innermost, the darkest portion that I was talking to you about, that contains unburnt wax vapor. This black part, not this blue part that is immediately above it. All right, the black portion where you had introduced that glass, thin glass rod. Okay, now immediately there is the blue flame, means there is some burning of carbon particles, but just above that there is a there is a layer of yellow zone. All right, that zone is the least hot. Okay, that is the least hot because there the vapors are just burning. The vapors are just burning. All right, so the most of the gaseous particles, they are burning on the upper portion, not near the wick. Okay, means the upper portion is, or you can say the middle zone of partial combustion, the luminous zone, the yellow zone, that is hot, that will be moderately hot, whereas the outermost zone of complete combustion, the blue zone, will be the hottest. I'm repeating this again. There is the innermost unburnt area that is black in color, where you had introduced that glass rod, that hollow glass rod, that will be the least hot area. It's the innermost, the darkest portion. And yes, you see a blue flame, but don't confuse that with that it will be very, very hot, since it's burning all the carbon particles. No, because immediately above it would be a yellow zone, the luminous zone. So that area would be the least hot, and the luminous zone, the yellow zone, the middle zone of partial combustion, which partial combustion of the carbon particles would be yellow in color and would be moderately hot. And the outermost layer, that has a bluish tinge to it, okay? And we have already established that the blue zone is the area of complete combustion. And since a complete combustion is taking place there, so that area would be the hottest part of the candle. Okay, so I think you can answer this question very confidently now. Goldsmiths blow the outermost zone of a flame with a metallic blowpipe for melting gold and silver. And why do they use the outermost zone of the flame? Because the outermost zone of the flame, as we had seen in the previous slide in the structure of a flame, the outermost zone of the flame is that zone where complete combustion is taking place. Okay, is that zone where it's the blue part, means the non-luminous part, not the yellow part, and it is that place that is the most hot, or you can say it is the hottest part. It is the hottest part of the candle flame. All right, so complete combustion is taking place, means all of the carbon particles are getting burned, little to no residue is being left behind. And since it is a complete combustion, so it is a non-luminous area, means the color is blue, and it is the hottest area. Of course, that is why they blow the outermost zone of a flame with a metallic blowpipe for melting gold and silver. So this was the part of the chapter where you learned about flame. So now we have learned about combustion, we have learned about ignition, and we have also seen the structure of a flame, which is the hottest part, which is the least hot part. Okay, in the next part of the chapter, which would be the final part, we will be discussing about the other, the base of the triangle that you were talking about, fuel.